We continue our adventure through section 6.2 with the following problem. Find the coordinates of the points where the line y equals 2x minus 2 and the circle x squared plus y squared equals 25 intersect. So we have two equations. One equation represents a line, one equation represents a circle, and it just so happens that these two geometric entities will intersect. And let's take a look where. So here is the graph of x squared plus y squared equals 25. The center of the graph is at 0, 0, and the radius is 5. Now, let's take a look at our y equals 2x minus 2. The y-intercept is negative 2. The slope is positive 2, up 2 over 1, up 2 over 1. And sure enough, these two graphs intersect. Right here is one intersection point at the point 3, 4. And down here it looks like negative 1.4, negative 4.8. Our job then is to use just the equations to determine these intersection points. This idea shouldn't be too new to you. Even in algebra, you were presented with what were called systems of linear equations. You were given two lines, something like this, and I'm just making these up on the spot. Y equals 2x, y equals 2x plus 3 rather, y equals 1/2 x, I don't know, minus 6. So these two graphs exist. One of them has a y-intercept of 3 and some sort of slope of 2. The other one, 1, 2, 3, 4, 5, 6 is the y-intercept, and it would have a lower slope, but still positive. So it looks like they might intersect over here somewhere. There's the second line. And to find the intersection point algebraically, you would usually use either the substitution method or the elimination method. I'm only going to show you what you would do for the substitution method for this one, because that's kind of the method we're going to use for this circle and line equation. For the substitution method, you take your definition of y from one equation, which is 2x plus 3, and you substitute it in for that, for the same variable in the other equation. So we end up with 2x plus 3 equals 1/2 x minus 6. Now we have one single equation with one single variable, and we can just combine like terms and isolate the x. We end up with 3/2 x equals negative 9. Multiply both sides by 2/3, and we end up with x equals negative 6. That only tells me half the story. That tells me that this point has an x coordinate of negative 6. However, if you want the intersection point, you would need to find the other coordinate. You can use either one of these linear equations. Plug in x equals negative 6, and it's going to spit out a y at you. I'll use this bottom one right here. Half of negative 6 is negative 3. Subtract 6, and we get negative 9. That's how it worked with linear equations back in the day, and we are going to take a very similar approach with our circle and linear equations. So let's take a look here. I guess I'll just erase this right here so we can focus on our work with circles and lines instead. I'm not going to sketch a graph of this. I'm just going to get right into it. In our problem, we have a definition of y. Y is 2x minus 2. Well, I can substitute that 2x minus 2 into my circle equation. Now I get x squared plus, instead of y squared, I'm going to plug in my definition of y, and that's 2x minus 2. This now is a single equation with a single variable, so it can be solved. It's going to end up being a quadratic formula because we have an x squared in there, and what we'll find is that we have another x squared coming up in just a second. I'm just going to multiply everything out. Right now it's just algebra, algebra, algebra. So let's see here. Minus 4x minus 4x plus 4. I just foiled that thing. I lobster clawed it. Now I'm going to combine all like terms, and I'm also going to try to move this 25 over if I can. x squared and 4x squared is 5x squared minus 8x. And then let's see here, 4 minus 25, that's going to be minus 21. At this point, I hope that it's factorable. If it's not factorable, I have to end up using the quadratic formula, that negative b plus or minus the square root thing. Turns out this one is factorable. With a little bit of playing around, you could get to this result. 5x, x, we're going to need a minus 3 here, and a plus 7 here. This gives us two possibilities for x. X is either negative 7/5 or x is equal to 3. So if we take a look back at our graph, we have x equals 3 up here. This negative 1.4, that's negative 7/5. So I did find the x coordinates correctly. Positive 3, negative 1.4. All I need now are the y coordinates. To find those, I can just plug in my x values into either one of the equations, but it makes more sense to use the linear equation, y equals 2x minus 2. At this point, it's just easier to work with. So let's take this linear equation to compute the two outputs. The first one is just 2 times negative 7/5 minus 2. The other one is y equals 2 times 3 minus 2. So when x equals 3, I get y is equal to 6 minus 2, 4. When x is negative 7/5 over here, we get y is equal to negative 14/5 minus 10/5. I went ahead and changed the denominator 2, and then I subtract 10, negative 24/5, which is what, 5, 10, 15, 20. That's negative 4.8. So the two intersection points are negative 7/5, which is negative 1.4, negative 4.8, and the other intersection point is what I say it was, 3, 4. So that match up, it sure does. Now, I should point out that there are different options, or different possibilities rather, for lines and circles. So in this particular example, we had two intersection points. Well, what if we had a different equation? So take a look at this equation. It's just it's not random. It's this very special equation because it only intersects one time. This is another possibility. So your result for these problems might give you two answers. It might give you one answer. In this instance, negative 3, 4 is the only intersection point. Or you might even have something like this. No intersection point at all. If you try to find the intersection point through algebraically of this circle, x squared plus y squared equals 25, and this line, you would get an error. You would end up with something impossible. Usually you would end up with the square root of a negative number at some point. So those are the three options. Either no solutions, one solution, or two solutions. And that should about do it. Thank you for your attention. Have a wonderful day.